So unprofessional. Okay, let's try that again. Today we're going to start out with a iPhone 6 Plus that is not charging. It does power on, however it does not charge at all. Let's go ahead and plug it into the USB. This is upside down, but the blue number is going to be amperage. Okay, when we plug it in, 0, nothing going on. This is a fully charged battery on here too. With a dead battery, it will not prompt the phone to boot, but it will pull about 0.44, which is interesting. However, the phone will turn on if we press the power button, which in this case is right here. And as you can see, it's trying to power on. The old tweezer trick. We're going to pull about 0.5 amp right now as it's booting. Once it powers all the way up, it goes back to 0. If I'm right. Okay, it's on. Alright, we're still at 0.48. Let's see if the computer sees it. The computer does see it. Yeah, let's hit trust. Let's see if we're getting any data sent to the computer here. Battery life. So we have a pretty nasty looking battery, 74% design capacity, 564 charge cycles. So this is probably a 2 or 3 year old battery. What we find is anything under 80-85% design capacity is actually a complete turd of a battery. Which makes sense. This is my old test battery. It's probably a complete turd. But it is sending actual data, so we know the battery SWI line is alive. However, when this thing's not pulling any decent amperage, let's see, we're still about 0.5 amp. Let's do this. Let's grab another battery that's not fully charged and see. Okay. Snarf Chris, you've got the best emojis. Everybody knows your emoji game is on point. That's what everybody says about you. Okay, this is live diagnosis as well. I have not really done anything except plug it in to confirm what the customer is saying. Okay, so with a not dead battery, we get prompt to boot, we get almost 1 amp. And we're back at 0.48. That is not good enough. Let's see what this battery percentage says. Okay, this battery is almost dead. We're only pulling 0.48. So this definitely feels super Tristar-y to me. Okay, now the battery's not quite dead. It's about it's about half. Let's go back to this and see what it's telling the computer. So step one with any kind of board repair is make sure you actually have a board problem and it's not just a crappy battery. Okay, this one is a 0 charge cycle. Can you believe that? I don't know. We're showing just under 50%. This thing really ought to be pulling more than half an amp. And that's with the screen on. This thing ought to be pulling 1 3/4. Alright, so let's turn the screen off. We're still 0.48. Alright, this one will not pull more than half an amp while the phone's on. Okay. I've seen enough. Let's throw a Tristar at it and see what happens. Heat up the old Weller. Old Yeller. Old Weller. Make sure I touch my face a bunch with these flux laced gloves. Alright. Oh, not that. That's a little better. The nice thing about this particular shield is it is the easiest one to get off of there. It's better. Better for you, not for me though. I was playing around with the bottom heater earlier today on a dead board. And this shield over Tristar, you can actually take on and remove without even applying any heat from your hot air station if you're just using the bottom heater on about 150. The solder they use here is like, it's like spit. It's just kind of sticky when it gets cold. Alright, let's do some work. Get my handy universal board holder. Not quite universal, but it fits almost all the iPhone boards. It's the best one I've seen. Let's see if we can improve this a little bit. I have a friend who has a better camera in this, and I asked if he wanted to trade if he uses it a lot. He's not streaming or anything, but he didn't want to trade me. I know, right? This guy. Okay. This one's got a bunch of underfill on it. So I think one day soon, oh my god, this camera is just annihilating everything. It's freaking terrible. Let's try. Oh, that is just the worst. Let's try that. Maybe, yeah. And then maybe a little bit of this. Oh my god. Coming soon to an eBay near you, this camera. I promise you'll like it. It'll work way better for you than it does for me. Dear God. Yeah, I don't know. We'll see. Apologies for the shitty microscope camera. There's a loose cap. So on my last TriStar video, I didn't test any of this stuff with the multimeter before getting started. And really, when I rewatched it, it was kind of dumb, because I could have probably saved like 30 or 45 minutes of BS if I just checked around for shorts around this chip. So let's do that. We're going to go diode mode. We're going to go red on ground, which is the top of the NAND is ground. These are all capacitors. One side is always going to be ground on these particular ones. The other side will be the living, breathing circuit. 270. What is that one? So nothing short. There's one reading 270, which doesn't seem great. Oh, that's PP1B8 SD RAM. That's fine. 270 is fine for that. Okay. So if our problem is TriStar, which at this point it's so easy to change and goes out so commonly. Let's get that off the screen. I don't think twice about popping a TriStar off of here. Let's crank that up to 11. Okay, she gone. Alright, let's get the rest of this crazy underfill out of here. Oh, this black tar goo. I think Apple realized that it wasn't necessary to underfill TriStar, as evidenced by the 6S and 6S Plus and 7. But then when they put it right next to the NAND on the SE, they underfilled it again. But they underfilled it with like the nastiest, way thicker underfill than this. Oh hey, there's an old Tigris. GTFO. Alright, so this is our cap that came loose. We're gonna give it a little attention before the new chip goes on. sure this ground side is, if it's attached at all, it's a cold joint. Yeah, not attached. Let's put some fresh soldier on it. Beautiful. Ooh, ooh, what are you doing? It's really hard to see, but the pad's actually flopping around in there. That's not what we want. That doesn't make anybody feel good. Alright, we're just going to tack it down right now. We got some fresh solder underneath it. When we heat up Tristar to go down, we'll touch that one real carefully and make sure that it gets seated as well. We just got it tacked in place right now on the live side. Let's clean up these pads a little bit. I'm not going to braid this. A lot of times I don't even pull the solder off of them. On a non-underfilled Tristar, you can usually just pull it straight up, plop your new one straight down where it was. Everything's nice and even. These underfilled ones tend to come off with a little bit less even pads. Let's get this cleaned up. Make sure it doesn't look like complete trash. Yeah, flopping our capacitor around a little bit, abusing it a little bit. Alright, there's this one ground pad. Guaranteed it's a ground pad. Yep. Why are you like this? Okay. A little bit of focused heat. Get this one ground pad to play nice. Alright. Let's grab a new Tristar. 1610A3. I got a few of those left before I switch to A3Bs on everything. Tristar chips, for the most part, are backwards compatible. So the A3, if you're familiar with it, actually goes on the 6S, but it works just fine on the 6. The A3B is on the 7, but it also works just fine on the 6S and the 6. They're not forwards compatible, so don't put an A2 where an A3 belongs. Nice thing about that is if you're trying to keep all the stuff in stock, just buy the newest one. With the exception of the 8, that's a 1612. And it's not even called Tristar anymore. Bummer. Guarantee they're going to die in exactly the same fashion, at exactly the same rates as the Tristars. We'll just be saying Hail Hydra instead. Alright. Give it some heat. Alright, we're watching the chip and we're also watching this cap. I want the chip to walk down. I don't want it to go up. If it goes up, it's gonna jump a whole row. There it goes, and no, that's not what we wanted. That's not what we wanted at all. Now I gotta make a jumper. You bastard. Okay. It's just a little jumper. Actually, you know what? I could probably make that jumper with the cap in place. That would be even easier. Let's just do that. Okay, you stay. And then we'll get a little bit of this action. Capacitor may not even be critical. You can see it's in parallel. You can see just by the surface trace that it's in parallel with the little one next to it. But it's easy enough to fix this little issue. We don't need to leave it off. We don't want it to feel left out. Just heat up the whole jumper. That's there. And then we'll get in there with the old tweezers. Come on, come on, come on. You can do it. You can do it. You did it. Okay. And we'll cut that little tail off just to maintain appearances. We did it. Okay. Alright. And maybe this whole phone is fixed. Everything else works on it. I was actually pleased that we were getting data. This guy might actually need a new charging port also. I was not getting a plugged in charging indicator. I was not getting any data to PC when it was fully installed in the phone. Clean out some of this flux. Sorry if that's annihilating your speakers. It's probably pretty loud. Stop looking at my love handles. Love handles. That's the grossest word. Should not be called that. We may drop this one in the ultrasonic before it goes out. That's a lot of kind of crystallized flux there. Anyway, for the moment of truth, let's see if that's all it needed. What are the chances? What are the odds? Honestly, the odds are, let's say 50-50. Half of these are just Tristar, half of them are Tristar plus Tigris plus something else demolished along the line. Okay, well, you can barely see this now. There's our ammeter. 104, 102, prompt to boot. We're over an amp consistently. What is it doing? One amp at 50% battery. That's pretty decent. 1.1, 109. Let's wait for the screen to go off and see what it goes to. Not changing much. Still getting data to PC. You can remember what Tristar does. Tristar does not charge the battery. That's Tigris's job. Tristar tells the phone that there's a charger plugged in, and it's got all these other little data lines on it. Oh well. Won't charge even with a new battery or a new charging port. CP. I'm gonna call that charging port. I think this one probably needs a new charging port. Alright, we still have a good connection to the computer. Instant amperage, negative 101. 195, now that the screen turned off. Computer can't put out enough amperage to properly charge a battery anyway. Let's look at this this Tristar chip for just another second here. So there's lots and lots. So this E75 is an important one. That's the signal from the lightning port that tells it it's a legit lightning cable. Then you have Tristar to AP JTAG SW clock, JTAG SW diode, SW single wire, bidirectional data line, what's that, BI? So that's basically the processor talking to the Tristar chip saying, hey, what do I do? You have lots and lots of just different important data lines, and it tells it all kind of stuff. So if you plug in a third-party, fan to cool yourself off, or I really like the Tinder swipe right robot that plugs into the bottom of the phone. It's funny, but if it doesn't have a legitimate MFI lightning connector on it, you're probably going to burn up this chip. And that's what happens all the time. Gas station chargers, they fake the E75 signal, they don't offer any overvoltage protection, and all these sensitive data lines in here just start going bananas. So Tigris actually does all the work of charging the battery, but it needs instructions from Tristar to actually do that. Alright, so we're going to call this one tentatively fixed. I'm going to say tentatively pretty much anytime something's fixed. Because I don't want this to come back. This is a mail-in repair. It costs customers money to mail it in the first place. And for me to do warranty work, if I didn't fix it all the way, also cost them extra money and time. So I want to be sure. I'm going to make it prove to me that it's fixed. So we're going to give this a nice thorough testing tomorrow. but we'll tentatively mark it fixed, and that means we've got time for a quick touch IC. I say a quick touch IC. This better be a quick touch IC. Let me go grab my screen. Okay. Quickies. Alright, touch IC. I've already done all the testing on this one. I'm not gonna sit here. Totally explain touch IC again. I'm not trying to be the touch IC guy on YouTube. Easy fixes. This is good. This is getting me back in my groove. If you do board level repairs, inevitably you're going to go through a couple seasons where it seems like almost everything that comes in is a no fix. It's this weird algebra that takes place, and even not, it's in every facet of this business. We've got parts in stock for phones that we haven't seen in 2 or 3 months, and then all of a sudden you'll get 3 of them come in the same week, and that's why those parts are in stock. Things like an LG G4, or we still get HTC M8s and M9s. Alright, so we're going to high heat right now. This is the hottest this board's going to get for this job, is to remove this touch IC. Boom. Not going to have to get that hot ever again, because we're putting some nice leaded solder paste. I'm going to make these balls beautiful again. Solder balls. Oh, talk about missed opportunities. I got obsessed with cleaning my silicone mat. Okay. It's always easier to clean these pads while the board's still hot from removing the chip. Your ground plane is a lot more amicable. But it's not worth heating the whole thing up again. There's a lot of trash in here, a lot of nasty little fuzz balls. What is that? What is that? It's disgusting. Shoot. Get. Be gone. Alright, we'll put some new solder down. Solder down now. Okay. Oh yeah, that's a good one. I'm allowed to say that about my own work. That's a good one. Alright, let's do our jumper. Yep. Oh, it would help if I prepared my pad. Hope this mic's not picking up all the guttural noises I'm making right now. If it is, well, this is what you signed up for. You're in it now! I see one pad it's got way more solder than I'd like. Okay, that one's good. This one, oh yeah, that's better. That, no, yep, that's better. Let's try this again. Jumper wire. Get down on it. Get down on it. And make a nice little smooth bend here. Oh yeah. Oh yeah. That's what I'm talking about right there. Right there. So pretty. I would like that to be sitting flatter, but yeah, it's secure. Alright, we'll cut the tail off. Everybody's favorite part. Time for the balls. Old solder gone. Clean it up nice and dry. Get back over there. There. A8. One little flux artifact there. I was doing some work at my other shop, and my solder paste there, I guess I left it sitting out one night without putting the top back on it. It's the best thing I've ever done. That paste is so dry. When you hit it with the hot air to reball, you don't get any of the flux boiling out and displacing your solder paste. It's just right. I think I'm gonna go ahead and just leave this one out all night tonight and see if it's better tomorrow. Because this, even like the stuff that I try and pile it up on the side of the container or give it a spot to maybe drain out a little bit, but you can see, I mean, it's still so juicy. Too much flux. some of that out of there. Get some uniform, even balls here. Let's see how that turns out. Let's go ahead and turn this down. And all the flux, everything that was in there is still just boiling right out. Most of the time you're still okay, as long as it doesn't migrate over to the next one. But sometimes it doesn't even want to stick to the pad because the whole blob just moved up. I don't know about these. I think we got some loose ones. Let everything harden. That one looks like crap. These all look like crap. Let's get the stencil off of here and see. Yeah, if you're having trouble reballing, check out your paste. You might be in the same situation as I am here, where if your paste was dried out a little bit, it will be way easier. Yeah, we got a little bit of nasties there. Let's move some of this out of here. That's what happens when the paste is too plentiful. It wants to just migrate all those tiny little solder balls. There's too much flux in there. Yeah, I'm leaving this paste out tonight. See if we can evaporate some of that and get it into more of a almost like a Play-Doh consistency is what you want. Maybe not quite that dry, but pretty close. Pretty close. Well, let's look at these from the side. I have a feeling I'm going to want to reball this again. I think these ones closest to us are bigger. Let's look at it this way. I don't know. Maybe it's just an optical illusion. Well, let's see if it rides. Dot goes there. Not permanently. Yeah, this is staying out. This is going to get some fresh air. And you need to go here. Okay, let's give it a little heat. Just a little bit. There's a pretty good bit of flux under there too, so I want to babysit it. I don't want it walking all over the place. So we'll go slightly slower for installation than we did for removal, just because these balls are going to melt at a significantly lower temperature than the unleaded stuff that was on there before. Okay, I think it's in place. We should get one little walk out of it. Come on, come on. Okay, that's it. Cool it up. Be cool, baby, be cool. Yeah, that flux made its way all the way under the PMIC. Pretty much covered this whole side. Let's clean some of that out of there. That's just sloppy. You can't leave it that way. Not allowed. This is a small letter mason chip, so if you're feeling superstitious, things are looking pretty good so far. It's going pretty smooth. Probably shouldn't have said anything. A little bit more. A little bit more. Get out of there, you. Go on now. Get on. My OCD's kicking in right now. Alright, let's test first. Can always clean later. Test. Dock. Screen. No, wrong screen. 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 I always like to test these with the customer's original screen because you can actually verify almost everything is working. Let's use this new battery. Might be time to retire that tester battery. I don't like that 74% report. That could potentially get us into the data corruption zone. That's really the last thing you want. I don't know what you want. The last thing I want. Okay, let's power on. Okay, we got an Apple logo. We got no distortion, so I didn't completely kill the phone. That's always a good sign, right? You're a professional repairman. Upon repair, stuff should not be completely dead. I did test this phone beforehand. Everything was working perfectly. We just had classic gray bars coming down from the top when you twist it. And touchscreen malfunction along with that. Okay, no passcode. No Touch ID message. Touch ID is good. You know Touch ID is good because your double tap without clicking will give you that accessibility drop down. No rear camera installed, but we can flip around to the front camera. That's working. Yep, that's working. And did I connect to Wi-Fi? Wi-Fi, baby. Wi-Fi is on. Probably not going to see much from here. Not without the antennas tied in. That's alright, so we'll test Siri microphone once it's back on the phone. Check, 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 test, 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 1, 2, 3. Proximity's working. I can hear the speaker. I can hear your speaker. You just gotta take my word for it. I wouldn't lie to you. Delete, delete. Alright, last thing is we're just gonna really carefully test this touchscreen, make sure our original screen didn't develop any stupid dead spots. I've heard plenty of other board level guys talk about it. I have not heard an explanation though as to why sometimes, and it's only if it's an OEM screen, will shit the bed. You'll get a consistent in it and a dead spot that if you put it on another phone, it's still there. But that screen, aside from having touch IC symptoms, when it does work, would perfectly. Alright, this one's done. This one's good to go. So we'll put this back in the phone. We'll give it a full QC once it's back together. And I've got like 2 more of these, but that's not a very exciting stream. So I think we'll call it there. Quick and dirty one. Thanks for watching. Have a good one.